All right, hello. Welcome to MCA review lesson here. Just need pencil, notebook, calculator out, and then try this warm-up question before we dive into the kind of the topics for today. So pause the video, give this a shot. All right, so they kind of give you a hint in this question that this is actually going to be a combinations question. Also know that is combinations because the order doesn't matter, right? All they want to do is advance. So there's 17 and we're picking 3, and the order doesn't matter. If you get picked first or second, you still advance. So it's 17 C3, and if you want to see that on your calculator, if you forgot how to do that, you got to type the 17 first and then go into, let's see, probability. No, math, and then go over to probability. Math over to probability. There's your permutations and combinations. So we're doing the order does not matter combinations. And so 3 are advancing. So 17 C3, and we get 680 as our answer. All right, so the focus of today, kind of two parts. Part one, we're going to do exponentials, and then we're going to talk about solving at the end. Okay, so an exponential function is usually there'll be a percent of increase or decrease. It's also a situation where you'd be like doubling or tripling. So if you're multiplying by a number, that's also exponential. And when you do a percent, you usually use this formula where you do the rate as a decimal. So like if it's increasing by like 2.5% or something like that, then you're going to use this little formula and then move the decimal over twice, and that's going to be your rate. There's a more general form of this where we just write like y equals a times b to the x. And this is just like you have a starting amount and then a number that you multiply by. So we'll do some examples like that, but it's just a more general version. You still have a starting number, and then you don't have this complex thing necessarily to figure out b. B is just like a number that you multiply by. So like like if you maybe have like $5 initially, and then that's going to double every year. We could write it like that, where you take 5 times 2 to the x, so that like in a chart sort of what you'd start off with is in year 1 you just have the $5. Sorry, year 0 you'd have the $5. That's the starting number, and then as x goes up 1, that increases this exponent by 1, and that just makes it double. So here you'd have 10 and then 20 then 40, etc. So you kind of have an exponential, you kind of have two parts, like a starting number and then a number you multiply by. Okay, so let's do a percent one. So here's a car, and cars do work like this. They depreciate or lose value 70%. Find the value after 5 years. So pause the video and see if you can remember how to do this formula here. Okay, so little a is 10,000. And then we're going to do 1 plus the rate as a decimal. So for 17%, it's like 17 out of 100. So you can do that in your calculator or just move the decimal place over twice. Should get 17 hundredths like that. And then the time is 5 years. Okay, and now it's really just a matter of typing it in on the calculator. 10,000. Oh, I messed this up actually. It's probably a good learning moment, right? So maybe you can see, what did I do wrong here? Okay, and so the answer is I lost value. So if you did it with a plus there, you'd get a bigger number. We got to lose value. So we got to do minus 17% on this one. So when I do this on my calculator, I'm going to do 1 minus the 17%, and then do it after 5 years. So put an exponent of 5. Okay, and we get only about like $39,039. Okay, so we lost a lot of the value there. And so we could ask kind of sort of a follow-up question. We know in 5 years we'd already lost more than half, but if you want to know like roughly when do we lose half our value, there's kind of a good way to do this on the calculator. So we're going to kind of take this expression, but make the year an x, and then use the table feature on our calculator. Okay, so what I would do is go into y equals, clear out anything that's in there, and I'm going to type in my little setup. 1 minus 17%. Okay, but now I'm going to make the year at x, right? So we don't know how long it's going to take to reach half its value. Okay, and then instead of hitting graph, I'm going to do second and hit the graph key to get to the table. And I'm way up high. Wow, that's annoying. But I'm going to scroll back up, and you can see the value after so many different years. So you can see for us, there is 5 years, which we had found earlier. But to do half its value, right, we started at 10,000. So half its value would be 5,000 would be about 3 to 4 years. So we could kind of just guesstimate from there and call it about 3.5 years, right? So we'll just say about 3.5 years. Okay, and usually on a multiple choice question, you just got to get in the ballpark, and that would be good for your answer. Okay, and so that table feature is really useful because you can see 5 years, 6 years, you can see any year. By making the exponent a variable, then you can check a bunch of different years all at once and also figure out when it's at half its value. Okay, so a couple more just kind of general ones. So this is the more general formula, and we want to try to write the relationship between the two variables because it's like an exponential situation. This one doubles every year, right? Okay, so we got to figure out the starting amount and then the number that you're multiplying by. Okay, so maybe pause the video and try these two and see if you can make some sense of it. Okay, so on this one, the followers equal 3 at the start, and then you double, so it's 3 times 2 each year. All right, so that would be our setup, and then we could make a little table so that if you wanted to say find the followers after 5 years, we just put 5 in for y, and it would be 3 times 2 to the 5th, whatever the heck that number is. All right, so there's your setup. Second one, the number of teams, and I know there's technically 68 teams now or something like that in the men's tournament, but we're going to say the number of teams is equal to 64 at the start, and now we're going to multiply by 1/2 each round. Okay, so then again, if we wanted to know like how many teams are in round 3, we could just do round 3, plug it in, and then figure it out from there. Right? So that's just a more general, and you'll see kind of both, like the rate formula. You might use that on the test, and you might just use this general one. So I'm going to next up just throw some sample questions at you, taken from like a sample MCA setup. So pause the video, read this one. It's a little bit different than what we've been doing, but pause the video and see if you can make some sense of it. Okay, so basically this is like the a times b to the x setup. So our starting number is 800, and we're losing half, or half remain. So we're going to have 50% here as our base. And then the trickiest part of this question is the exponent. So t is the number of hours, but half of them remain in a 10-hour interval, right? So that just means like if hours were 10, we want our exponent to be 1 because that's 1 10-hour period. And then like if hours was 20, we'd want the exponent to be 2 because that's 2 10-hour period. Hours 30, we'd want the exponent to be 3. So what we end up having to do is take whatever the time is in hours and divide that by 10 to get the exponent because we want to do 10-hour periods, right? We have to divide these by 10 to get the exponent that we want. Okay, so that's sort of the setup to calculate how many bacteria remain. And then we want to know when will that equal 200. So that makes our right answer letter B. Okay, and all these are slightly different. So here's another one. Kind of read through it and see if you can make sense of it. Okay, so this is another ABX one, where A is the starting amount of cells, which is 3, and then they double every hour, so it'd be 3 times 2 to the x. Okay, this one's a pretty tricky one. My hint on this is maybe make a table where we've got, I think, the hours and the number of bacteria P. So this one's kind of tricky, but I'd do a table here and see if you can make some sense of this. Okay, so the initial population of bacteria is P, right? So after 0 hours, we have P, and then after 3.5 hours, we've doubled, right? So we have 2P, okay? And we want to know after 20 hours. So after, if we go again, another 3.5 hours, we'll double again. So I'm just doubling this. And then if I go another 3.5 hours, I'm going to double again. And then if I go another 3.5 hours, I'm going to double. And then another 3.5 hours, I'm going to double, so 32P. And then it doesn't fall quite right because if I add another 3.5 hours, I get to 21 hours, I think. And I'm going to be at 64P. So the number we're interested in is right in here. We want to know after 20 hours. Okay, so we can kind of figure it out that 64P is too much because that would be after 21 hours. And these two answers aren't any good. So the best answer would just be letter C. We'd be at about 50P. That's a tricky one. Okay, one last one here quick. Okay, so she starts with 42,000. So basically this is going to be the other formula, the rate formula. Okay, and the initial amount is 42,000. I'm going to do 1 plus the rate, so 4% as a decimal. Move it over twice. So we're going to get a raise, so we're going to add that 4% each year, T. And then this is the beginning of the 10th year. And so what I think is really confusing on this, and actually why this is somewhat of a poor question, is the exponent isn't 10, right? Because she doesn't get a raise the first year, and we're at the beginning of the 10th year, she's only had 9 raises. So I think this is kind of a poor question. But I think the way it's worded, you have to be kind of careful because they want the exponent to be 9. So if you put that in your calculator, you will get no more than 59,000. So I think to the nearest $1,000, that would be $60,000. Yeah, so this is kind of a poor question, to be honest. Hopefully on the test, it's a little more clear than this, but read it carefully because I think they're trying to trick you on this one. But just know that, you got to be a little careful. Most of the time, I think you just put in 10, but the way this one's worded, I think they only got 9 raises, so you put 9 there. Okay, that's it for part 1. There'll be another video coming up here about solving.